Hello, this video is for IXL Activity A1.F.4. It is titled Volume. The 3-character code for this activity is Bravo Kilo Niner. So here we have a cube, and they want to know what is the volume of it. Well, the cube is kind of like a rectangular prism, and a rectangular prism, the volume for that is, and I'm going to try to draw a rectangular prism here a little bit there. My art skills aren't the greatest. A little bit more down. There we go. So the volume for a rectangular prism is length times width times height. This being the length, this being the width, and this being the height. That is, assuming that the bottom here is our base. Now, the thing about a cube is that the length, the width, and the height are all the same value whenever we're talking about a cube. So we could rewrite this as the volume of a cube. And I guess I could actually just write the word cube there, but that would be much more fun to draw the pictures, right? So volume of the cube is going to be the side lengths cubed, because since all three of them, the length, the width, and the height, are all the same value, we would just have the same number being multiplied times itself 3 times, and we don't really refer to it as length, width, and height in this case. We're just going to call it the side length. So volume of a cube is equal to the side length cubed. So with that said, let's go ahead and do volume equals, and we're going to take 8, and we're going to go ahead and cube that. And I'll do that on my calculator here. I think it's 500 something. 8 to the power of 3 is 512. So volume equals 512. And therefore, this answer would be 512 cubic centimeters. Let's look at the next question. What is the volume? And here we have a triangular prism. Now, the thing about a triangular prism, let's go with volume, is going to equal the area of the base. So let's see. I'll put area of, let's call it the base area. Instead of area of base, let's just call it the base area. So we're going to take the base area, and then we are going to multiply it times the height, H-E-I-G-H-T. So in this case, let's go ahead and consider what is the base. Well, the base of a prism is the two sides that are the same exact shape. So in this case, we have a triangle on this end, and then this back side is also a triangle on this end. So the triangle is the base. That means that this is going to be the height right here of the prism that we're going to use whenever we get to this height part over here. So let's go ahead and consider what is the area of the triangle. So the base area of the triangle, well, we know that for a triangle, it is 1/2 times base times height. And for height on the bases, I'm always going to refer to this as height 1. And then for the height of the prism, later on, we're going to get to pyramids. That's why I'm kind of stuck in my head here. But for the height of those, we're going to refer to this as height 2. So let's go ahead and start plugging some values in. So 1/2, I'm going to represent 1/2 as 0.5. The base of this is going to be the length right along here. So it's this 4 here, the base of the pyramid, or the triangle, the base area, the triangular base area. And then the height of the triangle itself is also 4, so we'll plug that in. And then the height of the prism we have here with this 3, so we'll plug in 3 there. So volume equals 4 times 4 is 16, right? 4 times 4 is 16, and then 1/2 of that is 8. So all that comes up to be 8, and then we're going to bring this 3 down, multiply that times 3, and 8 times 3 is 24. So in this case, the volume of this triangular prism will be 24 cubic millimeters. On the next one, we have the volume of a cylinder, and they want us to use 3.14 whenever we get to pi, because we're going to need pi. So let's go ahead and talk about the volume of a cylinder, and maybe I can draw a little cylinder there. So volume of a cylinder is going to be the base area. So again, we have the base area, and we're going to multiply that times the height of the cylinder itself. And since this is kind of height well, we really don't have height there in the base area, so we don't have to mark it as height 1 or height 2. We can just call it the height. So let's go ahead and plug in some values here. The base area, well, whenever we're talking about the base area, I'm talking about the actual circular shapes that are at the top and the bottom. So the base is going to be a circle. And we know that the bottom is identical to the top, so we'll use the figures from up top here. The area of a circle is pi r squared, so we're going to go ahead and put in pi r squared, and then we would have the height of the cylinder again. So really don't need the multiplication sign there, and just put in the h. So let's go ahead and start substituting some values. Let's use 3.14. 3.14 for pi. We're going to multiply that times the radius squared, and the radius is 10, and I'm going to square that. And then the height is 9, so we'll plug that 9 in there. So we're ready to do some calculations here. So volume equals, well, 10 squared is what, 100, right? And then multiply that times this 3.14. The decimal is just going to move over 2 places, so we're going to end up with 314. Now let's bring the 9 down. Multiply that times 9. And volume equals 314 multiplied times 9 will give us 2826. 2826. So 2,826 cubic centimeters is our answer. Here we have a rectangular prism. Well, remember, for a rectangular prism, back on that first slide, I said that it is, and as I get down with my art class here, there we go. The volume for a rectangular prism is going to be our length times our width times our height. So let's go ahead and plug those values in. We have a length of 7. We're going to multiply that times 3. And then we're going to multiply times the height, which is 8. So volume equals 7 times 3 is 21. And 21 times 8 would be 168. 168. I will verify that with my calculator. 21 times 8 is indeed 168. So 168 cubic millimeters. Again, volume of a rectangular prism, length times width times height. Next, we have a triangular pyramid. So pyramids have a special feature in them. If these were prisms and our sides were, I want to think about this way. Let me see, can I draw that? If these were prisms, they would look something like this instead. See if I can kind of pencil this in here so make a picture for you. I think we would be, and if I went straight up with this, and over to here, and then across there. So think of it this way. Picture it if it were a prism, kind of like this along here, and you want to be able to see, and then this side here would be connected here. It'd be a straight line though, can't be exact. And then that would be a dotted line so that you can't really see it in the back there. So now, can you kind of picture this if it were a prism instead of a pyramid? If that were the case, we would do the surface area, right? We would go ahead and do the base area. And we would then multiply it times the height of the prism. But it's not a prism, it's a pyramid instead. So look at all this empty space. If the pyramid were inside of the prism, the pyramid only takes up a certain amount of it. Look at all that other area that would be, or other volume, to be exact. Look at all the volume here that is actually emptied out. And it turns out to be that in the volume of a triangular pyramid, can I draw one of those? Something like that. For the volume of a triangular pyramid, all pyramids have this 1/3 concept in them. We're going to have 1/3, right, of that. See that space in there? If it were a prism, only 1/3 of it is actually being filled by the pyramid itself. So in this case, we need 1/3, and then we're going to go ahead and multiply that times the base area. And then we're going to multiply it times the height of the pyramid itself. So I'm going to go ahead and erase all of this over here, and let's go back to that. I just want to kind of fill that in so you can kind of see where this 1/3 is coming from, the concept of the 1/3. So let's go ahead and start plugging values in. So let's go ahead and bring down our 1/3 for now. We'll put that there. And then we're going to do the base area of the triangle. Well, I noticed that this is a right angle right here. See, there's a right angle notation here. So I know that with that information, I can tell that I can either pick 14 to be the base and 12 to be the height, or I can pick 12 to be the base and 14 to be the height. It doesn't matter either way that you go. This is a right angle. So one side's going to be the base, the other one's going to be the height. And remember, for a triangle, it's 1/2 times base times height. So let's go ahead and put that in. 1/2 times base, and let's pick the 12. And then let's pick the height, 14. And then put all that in parentheses. And then let's take the height of the pyramid itself, which is 11. Right? So put 11 in there. So let's go ahead and we'll leave the 1/3 here. Let's rewrite this here. I'm going to go ahead and rewrite this as 0.5. And I'm going to multiply that times 12 and multiply that times 14. And then I'm going to keep my 11 here. We'll just kind of do these in steps and stages. Let's bring the 1/3. And now let's go ahead and calculate 0.5 times 12 times 14, and we get 84. So I'll multiply that times 84. And then let's bring down the 11, multiply times 11. So volume equals 1/3 times, let's go 84, multiply that times 11, I get 924. Now, if I multiply 1/3 times 924, I'm going to get, and I'm going to go ahead and write it out here so you see it. I would end up with 924, because 924 times 1 is 924 over 3, which means I'm going to divide, because every fraction is a division problem. So 924 divided by 3 is going to give me 308. 308. So my volume will be 308 cubic millimeters. Again, key thing to remember about pyramids, it is 1/3 times the base area times the height. On this one here, we have a cone. Cone's kind of like a circular pyramid if you think about it. So our volume is going to be the concept of the 1/3 is going to be in there. And then we're going to take the base area, and then we're going to multiply it that times the height of the cone. So let's go ahead. 1/3 equals, or volume equals 1/3. The base area is going to be pi r squared. Well, for pi, we're going to use 3.14, so 3.14. And we're going to multiply that times the radius, which is 5. We're going to square that. So there's the base area, pi r squared. And then we have the height. In this case, the height is 13. So that's where I get all my values from. And now I will go ahead and keep the 1/3 here for now. Let's do 3.14. And I'm going to multiply that times 5 squared. The calculator is going to keep all of the order of operations squared away for me. So I don't need a 3 there. I need a 78.5. 78.5. And then I'll multiply that times 13. Now let's go ahead and I will keep the 1/3 for now. 78.5, multiply that times 13. I'm going to get 1020.5. And now I will go ahead and divide the 1020.5 by 3. Be the same as multiplying that times 1/3. So divide by 3, and I get 340.1666, and the 6's just keep going. So this is a repeating 6. Now they say to round to the nearest hundredth. So let's identify the hundredths place. Look to the right. This is a 6, so that means that the 6 here in the hundredths place is going to become a 7, and I would have 340.17 cubic yards. Then from there, the next questions, as they get more difficult toward the end of this activity, they actually give you the volume, and then they want to know what is one of the missing variables. In this case, they want to know what is the value of t, that is the height of the base here. So triangular prism, let's remember that volume is equal to 1/3 times, and I'm going to do BA for base area this time instead of writing the whole thing out, times the height of the prism. So Wrong. It's not a pyramid. I don't need the 1/3. So I have the base area times the height, right? So in this case, volume is going to, they do give us the volume. I seem to be lost here today. 1560 is our volume. Our base area here is going to be that of a triangle, so it's 1/2 times base times height. So 1/2, I'm going to put as 0.5 times the base, which is 13, times the height, which is the unknown variable of t, times the height of the prism itself, which is 15. So now I've just taken the formula and I've plugged everything in, and then I'm going to now solve for t. So let's go ahead and take 1560 equals, and 0.5 times 13, 0.5 times 13 will give me 6.5, 6.5 t, and I need to multiply that times 15. So now let's go ahead and 1560, I could do it all this. I want to do it step by step. I could do it real quick like on my calculator here all in one foul swoop, but I want to work through it step by step so you kind of see everything that's going on. So let's do the 6.5 times the 15. 6.5, multiply that times 15, and I'm going to end up with 97.5 t. Now let's divide both sides by 97.5. 97.5. These 97.5s are going to cancel each other, leave me with just the variable t, and 1560 divided by the answer, 97.5, is going to give me 16. So the value of t here is 16 yards. So this right here, 16. Again, we do this by substituting in now. Instead of them giving us all of the information and calculating the volume, we're just going to plug in the volume and then find out where we have our missing information over on the other side and then solve for that variable. On the next one, here we have the volume of this cube is 216 cubic inches. What's the value of P? Well, volume of a cube, and that's not a very good cube, but at any rate we know is S cubed. So let's go ahead and put in what we do know. We do know that the volume is 216. 216 equals S cubed. Now we need to know the side length. So if we take the cubed root of both sides, if we take the cubed root of 216 and the cubed root of S cubed, what we do to one side, we do to the other. Oh, and I need a 3 there, right? And I need a 3 here also. So they're cube roots, not square roots. So I'm going to have to go into my menu button on there. If you hit math menu on your graphing calculator, and the first menu that it pulls up is the math section. If you go down to number 4 on a TI-84, item number 4 is your cubed roots. And it will go ahead and just simply put in, let me see if I can show that there. Will it focus? Yep, see? And if you look and pull that up, it'll pull up a little cubed root box. And then you can just type in the value that you need the cubed root of. In this case, it's 216. So I'm going to go ahead and put in 216 and hit enter. And it turns out to be that the cubed root is S equals 6. You could always go back and verify this by taking 6 and cubing it. 6 to the 3rd power is indeed 216. If you did not have a calculator that would do that, you could just start cubing numbers. 4, wouldn't be enough. 5 times 5 times 5, wouldn't be enough. Try 6 times 6 times 6, and then you get 216, and you'd be able to find it that way. But moving along. The volume of this cone is 4,239 cubic inches. What is the height of the cone? Use 3.4 to round your answer to the nearest hundredth. So the volume of a cone. So we have volume of a cone equals, it's kind of like a circular pyramid. So we have the 1/3, the base area, and then the height of the cone itself. So do they give us the height? Oh, that's what they're asking. What is the height of the cone? So what we're missing is this value right here, this height of the cone right there. That's what we're missing. We'll call it, we'll just call it H, right? So volume, oh, nope, volume is what we have. We want to put an actual value in there. 4239 equals 1/3 times the base area. In this case, it's pi, which is 3.14. 3.14 times the radius, which is 15 squared, pi r squared, and times the height. So right here, height is what we need to solve for. So 4239 equals 1/3. Let's do 3.14. 3.14. We're going to multiply that times 15 squared, and that's going to give us 706.5, and we still have the H. Now 4239 equals, I'm going to do 706.5 divided by 3. Let's divide that by 3. That would be the same as multiplying times the 1/3, and I'm going to end up with 235.5. And let's bring down this H. Now I need to divide both sides by the coefficient of 235.5. And what I do to one side, I'm going to do to the other. So these would cancel each other out, leave me with the H. And 4239 divided by the 235.5 is going to be 18. So in this case, my height of this cone is 18 inches. The volume of the cylinder is 11,304 cubic millimeters. What is the radius? And again, we're going to use 3.14 as the for pi, and we're going to round to the nearest hundredth. So volume for a cylinder is equal to the base area times the height, right? So base area times the height. So let's put in what we know. We know the volume is 11,304. And for base area, we're going to do pi r squared. So we have pi, 3.14. And we're going to multiply that times, I guess I'll use a dot in there. Let's go ahead and multiply it times r squared. That's the base area, and then the height is 16. So I have everything plugged in. So 11,304 equals. Now, realize that this is all multiplication along here, right? So we could go ahead and do the 3.14 times 16. I'll go ahead and do that. 3.14. I'm going to multiply that times 16, and that's going to give me 50.24. And I still have the r squared is still there. Now let's divide both sides by 50.24. 50.24. So those will cancel, leave me with r squared, and then 11,304. And I want to divide that by the 50.24, and that's going to give me 225. Ooh, that is a perfect square, if I recognize that. I'm trying to remember what it is. Is it 15 maybe? Let's go ahead and take the square root of each side, right? By taking the square root of each side, we would then end up with just r on the right, and then the square root of 225 equals, indeed it is, 15. So the radius is 15 millimeters. What is the volume of this cube here? So we're kind of back to some easy stuff, right? Volume equals the side lengths cubed. So let's go ahead and plug that in. Volume equals 39.4, and we're going to cube that. So volume equals, let's do 39.4 to the power of 3, and gives us 61,162.984. Notice they don't ask for us to round this anywhere, so we want to put that in, 61162.984. If it doesn't ask you to round to a certain place value, then put in the entire answer. And here's our final question, or final example for this activity. The volume of this triangular prism is 500 cubic yards. What is the value of B? So remember, volume is equal to the base area times the height. So our volume's 560. We get that from right here. They give us the volume. The base area, oh, see, we're missing our base right here, but the base area of a triangle is 1/2 times base times height. So 1/2, I'm going to represent as 0.5, times the base, which is b, times the height, which in this case is 10. And then, so all this right here is the base area of the triangle. 1/2 times base, which is b, looks like a 6. Let's call that an x. Let's go smaller here. So I'm going to call this x instead of b. That way it doesn't look like a 6. And so all that's the base area of the triangle. And then after that, we need to go ahead and multiply also by the height here. And the height is 8. So multiply times 8. So 560 equals, let's do the 0.5 times 10 times 8. Well, 10 times 8 is 80. And 1/2 of 80 is 40. And bring down the variable x. Now let's divide both sides by 40. And 560 divided by 40 equals 14. And there we are. X equals 14. Does that seem to make sense? Indeed it does. If this were 14 right here, looks a little bit longer than that, a little bit longer than that. Yep, 14 seems like a reasonable answer for this particular problem. All right, so that completes all of my examples for IXL A1.F.4 Volume. Good luck with your activity.